Hello. While some of your videos will be from other sources, a few I will create for you as well. This is for lesson 2-4 and it's specifically going to cover 2-4a. You'll end up with a total of 4 videos. One's going to cover, I should say, our first learning objective, understanding the nature of solving a system of linear equations. That's what this video is about. You'll have separate videos for solving a system graphically, which I will create, and then videos for substitution and elimination, which will be videos from other folks that have been shared with me. So let's talk about understanding the nature of solving a system of linear equations. A system of linear equations for us is going to be something that involves 2 equations and 2 variables, and kind of in the middle of the page here you can see such a system. 2x plus y equals 7 and y equals 2x minus 1. What we're going to be doing is looking for a point, some combination of an x-coordinate and a y-coordinate, that satisfies both of these equations. That is, makes both equations true at exactly the same time. As we see a little bit further down the page here, graphically what that means is we're going to be looking for where 2 lines intersect. And that's just what's going to happen most of the time. Most of the time our 2 lines are going to intersect. We're going to have a single solution. For the system that you see up here, I've written over on the left-hand side the solution to it, which is the point 2, 3. Any other combination of x and y will not make both equations true. There are lots that will make the first equation true. There are lots that will make the second equation true. But there's only one that makes them both true at the same time, and that's 2, 3. On the right-hand side, I've substituted into each equation using x equals 2 and y equals 3 to show that that is true. In the first equation, 2x plus y equals 7. If I replace x with 2 and y with 3, I get 2 times 2, which is 4, plus 3. That is indeed 7. In the second equation, y equals 2x minus 1. I replace the y with 3, the x with 2. And if we focus on the right-hand side, 2 times 2 is 4, minus 1 is 3, and that's exactly what we have over here on the left-hand side. So that is a point that satisfies both, and therefore it is a solution for the system. Solutions for the system have to make both equations true at the same time. Any point you find that makes one equation true but the other equation is false is not a solution to the system. It's a solution for one of the particular lines, but not for both. So there are 3 different possibilities for the number of answers. We can have one answer, we can have 0 or none, and we can have infinitely many. In the situation where we have one answer, which is what happens most of the time, the 2 slopes of the lines will be different. So if you put your lines into slope-intercept form for graphing first, you'll quickly see whether they have one solution by whether the slopes are exactly the same or if they are different. If they are different, you will get exactly one point of intersection. Your 2 lines will cross in just that one point. Such a system is called consistent because it has a solution, and independent because the equations are not the same. It's possible to have 0 solutions. In that case, the slopes of the 2 lines are the same, meaning the lines are parallel to each other, but the y-intercepts are different, or the y-coordinates of the y-intercepts, I should say, meaning that the 2 lines are distinct from each other. So they are parallel and not the same line. We call this an inconsistent system because it has no solutions. A third possibility is infinitely many solutions. In that case, the slopes of the 2 lines will be identically the same, and the y-coordinates of the y-intercepts will also be identically the same, meaning that the 2 lines are identically the same. They graph as exactly the same line. We call such a system consistent and dependent. Consistent because it has at least one solution. Dependent because, in this case, the 2 equations or the 2 lines end up being the same line. When we write our answer to a system with a single answer, we write it as an ordered pair. For example, the 2, 3 you see in the upper left here. When we have a system that has no solution, we say that it has no solution. When we have a system that has infinitely many solutions, we can't just say infinitely many because we only want to talk about the infinitely many that show up on the line, not the even larger infinitely many that aren't on the line. So typically in this situation, we give one of the equations back in slope-intercept form as a solution. That is, pick an x, use that equation to find a y, and all of those pairs, there are infinitely many of them, make up all the solutions that work. At the top of the next page, you have some cooperative group problems you can try, and you should go ahead and do those. If you have any questions about them, please let me know.